Ladies and gentlemen, what if the machines building the future are already smarter than the people watching them? Right now, hidden inside massive automated factories, thousands of robots are moving with terrifying precision, creating vehicles, batteries, and artificial intelligence systems faster than most people can even imagine. These machines never sleep, never slow down, and every single second they are learning, evolving, and upgrading themselves. What's happening behind those closed factory walls is so advanced it feels less like modern technology and more like the beginning of an entirely new civilization powered by automation, speed, and machine intelligence. And the next wave of intelligent mobility is no longer about adding small features to vehicles. It is about transforming the entire driving ecosystem into a fully connected, constantly evolving machine network. The latest massive update rolling out across the platform is designed to push every system further into the future, turning ordinary daily driving into something that feels automated, predictive, and deeply integrated with advanced digital infrastructure. And the moment the update activates, the vehicle begins operating less like a traditional car and more like a high-performance intelligent device on wheels. Every screen response becomes sharper. Every system reacts faster. Navigation feels almost predictive, processing live environmental data with machine-level precision. Instead of simply reacting to traffic, the system continuously scans movement patterns, charging station loads, weather conditions, and road behavior in real time, optimizing routes before delays even appear. And one of the most talked about changes is the dramatic expansion of automated driving intelligence. The neural processing systems now interpret surroundings with greater depth and speed, allowing smoother lane transitions, more natural turns, and improved awareness in complex urban environments. Cameras, sensors, and onboard computing systems work together like a synchronized digital organism, processing massive amounts of visual and environmental information every second. The result feels less mechanical and more futuristic, almost as if the vehicle understands traffic flow before it happens. And the update also introduces a redesigned interface experience inspired by advanced control systems used in high-speed engineering environments. Menus load instantly. Visual animations feel fluid and responsive. Energy consumption data updates dynamically with precise real-time metrics, giving owners a deeper look into how the machine manages efficiency at every moment. Charging predictions have become smarter, as well, calculating battery behavior with greater accuracy across temperature shifts, terrain changes, and driving styles. And inside the cabin, automation reaches an entirely new level. Climate systems now adapt more intelligently to passenger habits, adjusting airflow, seat temperature, and environmental balance with minimal manual input. Voice interaction becomes faster and more conversational, reducing delays between commands and execution. Even entertainment systems have evolved into a more immersive digital environment, with smoother streaming performance, expanded processing speed, and enhanced synchronization between devices. But the real breakthrough lies beneath the visible surface. The update dramatically improves the communication architecture between the vehicle and cloud-based systems. Massive amounts of operational data are exchanged continuously, allowing machine learning models to refine performance on a global scale. Every mile driven contributes to a larger intelligence network, helping vehicles adapt faster, safer, and more efficiently over time. It creates the feeling that the system is constantly learning, constantly evolving, and constantly preparing for the next stage of autonomy. And battery management technology also receives major enhancements. Power distribution algorithms now respond more efficiently during acceleration, long-distance driving, and rapid charging sessions. Energy flow is optimized at a microscopic level, reducing unnecessary waste, while increasing responsiveness. Drivers may notice smoother acceleration curves, more stable energy usage, and improved charging consistency during extended travel cycles. And security systems have become more advanced as well. The vehicle now monitors digital and physical access with upgraded encrypted communication layers designed to respond instantly to unusual behavior. Cameras remain more aware during parked conditions, and automated monitoring systems provide quicker alerts through connected mobile platforms. The entire ecosystem feels less like a standalone machine and more like a protected intelligent network node. And the scale of the update is what makes it so remarkable. This is not a simple patch or cosmetic redesign. It is a massive software evolution distributed simultaneously across thousands of connected vehicles, transforming performance overnight without requiring owners to visit service centers or replace hardware. Machines parked silently in garages suddenly wake up with new capabilities, new intelligence, and new levels of automation, all delivered through invisible digital infrastructure operating at global scale. And what makes this especially fascinating is how seamlessly the technology integrates into everyday life. The systems operate quietly in the background, reducing friction in ways most drivers may not immediately notice. Routes become smoother, charging becomes faster, navigation becomes smarter, automation feels more natural. The machine gradually removes small inefficiencies until the entire experience feels engineered from the future, rather than adapted from the past. And behind it all is an increasingly powerful artificial intelligence architecture processing enormous streams of real-world data, every second refining decision-making models across millions of driving scenarios. The more the system learns, the more capable it becomes. Roads become datasets, vehicles become intelligent processors, infrastructure becomes connected, transportation becomes automated at a scale that once sounded impossible. And that transformation is becoming even more visible inside the production systems responsible for building the machines themselves. Gigantic automated factories now operate like synchronized mechanical ecosystems, where robotics, artificial intelligence, and high-speed manufacturing systems communicate continuously without interruption. Every robotic arm, conveyor system, scanning device, and assembly platform functions as part of a larger neural production network designed to maximize speed, precision, and scalability at levels traditional manufacturing could never achieve. And inside these facilities, machines move with near-perfect timing. Massive robotic structures lift entire vehicle frames effortlessly, while advanced laser systems inspect microscopic alignment tolerances in real time. High-speed vision systems scan thousands of components every minute, identifying imperfections smaller than the human eye can detect. The entire environment feels less like a factory and more like a living automated intelligence center, powered by endless streams of data. And artificial intelligence has now become deeply embedded into every stage of production. Instead of relying only on fixed programming, manufacturing systems analyze performance continuously and adapt dynamically. Robotic systems learn optimal movement paths, adjust energy usage automatically, and predict mechanical wear before failures occur. Entire assembly lines can now reorganize production flow instantly depending on supply conditions, demand shifts, or efficiency targets. Machines are no longer simply executing commands. They are actively optimizing themselves while operating at full scale. And one of the most fascinating advancements comes from the integration between vehicles already on the road and the production systems building future generations. Real-world driving data collected from millions of miles feeds directly into machine learning models used inside manufacturing facilities. If certain driving patterns reveal opportunities for structural improvements, thermal efficiency upgrades, or software refinements, the production network adapts rapidly. Factories evolve almost in parallel with the vehicles themselves, creating a feedback loop where machines continuously improve machines. And battery production systems have become especially advanced. Gigantic automated lines process raw materials with extreme precision, using robotics capable of handling delicate components at incredible speed. Temperature, pressure, humidity, and chemical stability are monitored constantly by intelligent systems analyzing millions of data points every second. Even microscopic inconsistencies are detected instantly through machine vision networks and predictive algorithms. The scale of coordination required is enormous, yet the systems operate with almost silent efficiency. And as production capacity expands, the architecture of these facilities becomes increasingly futuristic. Automated transport platforms move materials through factories without human intervention, navigating independently using sensor grids and real-time spatial mapping. Components arrive exactly when needed, reducing waste and eliminating delays. Storage systems communicate directly with robotic assembly stations, creating a manufacturing flow that resembles a digital nervous system more than a traditional industrial process. And meanwhile, the artificial intelligence powering autonomous systems inside the vehicles continues evolving at extraordinary speed. Neural networks process visual information with increasing sophistication, interpreting road conditions, object behavior, environmental patterns, and movement trajectories simultaneously. Cameras act as machine eyes, constantly capturing enormous volumes of data, while onboard processors convert that information into rapid decision-making models capable of operating within fractions of a second. And the computing hardware supporting these systems is equally astonishing. Advanced processors inside the vehicle now perform trillions of operations, continuously enabling real-time environmental analysis on a scale previously limited to massive data centers. The vehicle effectively becomes a mobile supercomputer, constantly calculating routes, energy optimization, safety predictions, and traffic behavior, while communicating with cloud-based intelligence systems operating globally. And what makes the update even more intriguing is the hidden layer of predictive automation quietly operating beneath the interface. The machine begins recognizing patterns long before drivers consciously notice them. It studies acceleration habits, charging preferences, route timing, climate settings, and even recurring traffic behavior. Over time, the system builds a digital behavioral model designed to reduce friction in nearly every aspect of mobility. The result feels increasingly seamless, as though the vehicle anticipates actions before they occur. And large-scale machine coordination is also transforming service infrastructure. Diagnostic systems now analyze vehicle health continuously in the background, identifying potential issues through predictive modeling before mechanical symptoms appear. Instead of waiting for failures, the system monitors vibration patterns, thermal behavior, battery fluctuations, and component performance proactively. Artificial intelligence evaluates these signals against enormous operational datasets, allowing maintenance systems to respond with remarkable accuracy. And even charging infrastructure is becoming part of this expanding intelligent ecosystem. High-speed charging networks communicate directly with vehicles, balancing energy loads dynamically across regions to improve efficiency and reduce congestion. Algorithms analyze travel patterns, predict demand surges, and optimize charging availability automatically. Vehicles approaching stations may already receive updated recommendations before arrival, based on real-time system conditions happening miles ahead. And behind every improvement lies an enormous invisible infrastructure of servers, machine learning clusters, automated simulation systems, and high-performance computing environments processing unimaginable quantities of information. Entire virtual environments are generated to train autonomous systems across billions of simulated driving scenarios. Digital machines practice responding to rare road conditions repeatedly inside simulation networks long before encountering them in the physical world. And as robotics become more advanced, the boundaries between software intelligence and mechanical engineering continue disappearing. Machines are beginning to function less like isolated hardware products and more like evolving intelligent organisms connected through continuous streams of computation, automation, and large-scale artificial intelligence systems operating around the clock. And across these enormous automated environments, speed becomes almost difficult to comprehend. Entire vehicle structures move through production lines with relentless momentum, while hundreds of robotic systems operate simultaneously in synchronized precision. Sparks flash across massive assembly chambers as robotic welders rotate with mechanical accuracy measured down to fractions of a millimeter. Gigantic aluminum panels glide through stamping machines with explosive force, transforming flat sheets of metal into complex structural components within seconds. Every movement feels calculated by an intelligence operating beyond normal industrial limits. And overhead autonomous transport systems move continuously through illuminated factory corridors, carrying batteries, processors, drive units, and structural modules between stations without stopping. There are no random delays, no wasted motion, no unnecessary pauses. Every route is optimized by predictive algorithms monitoring factory activity in real time. The deeper the system scales, the more the entire facility begins resembling a giant computational machine, rather than a traditional manufacturing plant. And inside battery production sectors, the atmosphere becomes even more futuristic. Endless rows of automated equipment process materials under perfectly controlled environmental conditions, while robotic handlers move with almost surgical precision. High-speed laser inspection systems scan surfaces, continuously identifying microscopic inconsistencies instantly before components move forward. Conveyor systems stretch across enormous distances, while thousands of synchronized machines assemble energy cells at staggering speed. The scale becomes almost overwhelming, with production lines capable of generating massive volumes of battery systems every single day. And artificial intelligence oversees everything from above like an invisible digital command center. Massive neural processing systems analyze thermal conditions, vibration frequencies, power fluctuations, assembly timing, and supply chain movement simultaneously. Millions of operational decisions happen automatically every second without human intervention. If one robotic system slows slightly, surrounding systems instantly compensate. If material demand changes unexpectedly, production flow reorganizes itself dynamically. The factories feel alive, constantly adapting, constantly optimizing, constantly accelerating. And even the sounds inside these environments create a strange futuristic rhythm. Metallic impacts echo through gigantic chambers, while robotic actuators move with rapid hydraulic precision. Cooling systems circulate through vast industrial networks. Autonomous carts glide silently beneath towering machinery. High-frequency scanners pulse across surfaces while robotic arms pivot overhead with impossible speed. Every section of the facility operates like part of one gigantic synchronized organism, engineered entirely around efficiency, automation, and scale. And then there are the casting systems, among the most visually astonishing manufacturing technologies ever integrated into vehicle production. Molten metal flows through gigantic automated casting machines operating under immense pressure and temperature control. Within moments, enormous structural sections emerge as single unified components, eliminating hundreds of smaller parts, once required in traditional assembly systems. The simplification dramatically increases strength, reduces weight, and accelerates production speed simultaneously. Massive robotic extractors remove glowing components while cooling systems stabilize the material with machine-level precision. And as vehicles move deeper into final assembly, automation becomes even more intricate. Robotic arms install wiring systems with perfect routing accuracy, while machine vision networks inspect every connection instantly. Glass panels descend into position with microscopic alignment tolerances. Interior systems synchronize automatically during installation, activating sensors, displays, processors, and environmental controls long before the vehicle even reaches completion. The machine effectively begins waking up while still moving through the factory itself. And what makes this even more remarkable is how software development now evolves alongside physical manufacturing in real time. Vehicles are no longer considered finished products at the moment of delivery. Instead, they function as continuously evolving technological platforms. Gigantic data centers process global fleet information, constantly generating software improvements that can transform vehicle behavior overnight. Performance systems, navigation, intelligence, automation, features, energy optimization, and interface responsiveness continue evolving long after production ends. And the deeper these systems integrate, the more transportation starts resembling a fully connected digital infrastructure, rather than independent machines operating separately. Vehicles communicate with charging systems, cloud networks, traffic databases, mapping environments, and large-scale artificial intelligence platforms simultaneously. Billions of environmental inputs flow continuously across this ecosystem, allowing the machines to refine their operational models constantly. And inside autonomous driving simulations, the scale becomes almost unimaginable. Massive computing clusters generate virtual cities, weather systems, traffic patterns, road hazards, and unpredictable movement scenarios continuously. Artificial intelligence systems train inside these digital worlds day and night, processing billions of simulated miles at accelerated speed. The machines repeatedly encounter situations too rare or dangerous to reproduce easily in the physical world, allowing the intelligence systems to evolve far beyond conventional driver assistance technologies. And at the same time, hardware systems inside the vehicles continue becoming more advanced and more densely integrated. Processing boards capable of extraordinary computational throughput analyze camera feeds, radar inputs, environmental mapping, thermal data, and navigation systems simultaneously. Cooling channels regulate processor temperatures, while energy management systems distribute power dynamically depending on computational demand. The vehicle essentially becomes a rolling high-performance data center operating at highway speed. And even the exterior manufacturing finish reflects this obsession with precision. Automated paint systems apply coatings through robotic choreography inside controlled atmospheric chambers where airflow, humidity, and particle contamination are monitored continuously. Laser-guided inspection systems analyze surface reflections at microscopic detail, ensuring consistency across every panel. The process feels more like aerospace engineering than traditional automotive production. And as production expands globally, the infrastructure supporting it becomes increasingly massive. Gigantic logistics systems coordinate material flow across continents using predictive artificial intelligence capable of forecasting demand fluctuations weeks in advance. Automated warehouses operate around the clock with robotic retrieval systems, moving components at astonishing speed. Supply chains adapt dynamically as machine learning systems optimize transportation routes, energy usage, and production scheduling simultaneously. And while all of this operates at industrial scale, the intelligence inside the machines continues becoming more personal, more adaptive, and more predictive. The systems quietly learn from behavior patterns, environmental conditions driving rhythms, and energy usage habits continuously. Every interaction becomes another layer of training data. Every mile strengthens the intelligence network further. Every software update pushes the machines closer to a future where automation, robotics, artificial intelligence, and massive industrial computation merge into one seamless technological ecosystem, operating with relentless speed and precision. And beyond the visible machinery and synchronized robotics, another layer of the system operates silently in the background, almost invisible yet controlling everything with astonishing precision. Deep inside massive server environments, endless streams of operational data pulse through high-speed computing clusters connected directly to the production ecosystem. Every robotic movement, every battery cell alignment, every microscopic weld, every software calibration is monitored continuously through artificial intelligence systems capable of identifying patterns long before human operators could ever detect them. It creates the unsettling feeling that the factories are no longer simply controlled by software, but are actively thinking, adapting, and evolving in real time. And at night, these facilities become even more cinematic. Vast industrial structures glow beneath cold white lighting while thousands of automated systems continue operating without interruption. Robotic arms move through darkness with mechanical fluidity, welding sparks briefly illuminating gigantic assembly chambers like flashes of electric lightning. Conveyor systems stretch endlessly into the distance, carrying unfinished machine frames through layers of scanning systems, alignment platforms, and precision assembly stations. The entire environment feels almost unreal, as though the future has already arrived behind closed industrial walls, hidden from the outside world. And inside these enormous production corridors, timing becomes everything. Components arrive within fractions of a second of their required assembly window. Autonomous transport platforms glide across polished factory floors carrying structural castings, processors, drive systems, and battery modules with exact positioning accuracy. Overhead intelligent cranes move massive sections of vehicle frames effortlessly through the air while synchronized robotics prepare the next phase before the previous task has even completed. Every machine anticipates the next action before it happens. And the precision becomes even more extraordinary inside the calibration zones. Newly assembled vehicles enter controlled testing environments where high-speed diagnostic systems activate thousands of internal functions simultaneously. Cameras analyze steering response. Sensors verify braking pressure. Thermal systems monitor heat distribution across processors and battery architecture. Artificial intelligence evaluates millions of measurements, instantly comparing each vehicle against enormous performance datasets generated across the entire production network. Nothing escapes analysis. Every sound, every vibration, every electrical signal becomes part of a constantly expanding intelligence model, refining itself continuously. And then there is the sheer scale of the operation. Entire sections of production facilities stretch across distances so large they resemble miniature cities dedicated entirely to machine creation. Endless rows of synchronized robots operate with relentless consistency hour after hour, day after day, producing structures with microscopic tolerances at volumes previously considered impossible. What once required thousands of separate assembly processes is now compressed into streamlined automated systems capable of moving at astonishing speed without sacrificing precision. And even the airflow inside these facilities is engineered scientifically. Temperature-controlled environments regulate material expansion down to microscopic levels. Advanced filtration systems eliminate airborne particles before they can interfere with sensitive electronics or surface finishes. Pressure systems stabilize production chambers where battery materials are assembled under carefully monitored atmospheric conditions. Every environmental variable becomes part of the machine ecosystem itself, controlled by intelligent infrastructure operating constantly in the background. And as the vehicles progress toward completion, the atmosphere inside final assembly areas becomes increasingly intense. Massive panoramic glass panels descend slowly into place while robotic alignment systems position them with near-perfect symmetry. High-speed fastening tools operate with calibrated torque precision measured digitally in real time. Beneath the vehicle, automated systems connect cooling channels, drive units, and power distribution architecture in rapid synchronized sequences that look almost too fast for the eye to follow. And then suddenly the machines begin activating, and displays illuminate across the cabin. Sensor arrays initiate environmental scans. Cameras awaken one by one, feeding live visual streams into onboard neural processors already analyzing surroundings before the vehicle even leaves the production floor. Cooling systems circulate quietly beneath the structure, while software systems initialize through layers of interconnected diagnostics. The transition is strangely cinematic, as though the machine is becoming conscious step by step inside the factory itself. And what makes the entire process even more fascinating is the level of predictive intelligence embedded throughout the ecosystem. Artificial intelligence systems are not only managing current production demands, but forecasting future behavior continuously. Algorithms analyze raw material availability, shipping timelines, energy consumption patterns, charging network growth, software deployment cycles, and global driving behavior simultaneously. Entire production strategies adjust dynamically before disruptions even occur. And far away from the factory's gigantic energy storage systems connected to renewable infrastructure help stabilize the enormous electrical demand required to sustain this level of manufacturing. Vast fields of battery systems charge and discharge intelligently based on grid conditions, production schedules, and regional energy fluctuations. The factories themselves increasingly resemble autonomous technological organisms powered by integrated energy ecosystems, operating with machine-level coordination. And meanwhile, simulation systems continue running non-stop. Inside powerful computing environments, artificial intelligence recreates endless combinations of weather events, traffic conditions, road hazards, infrastructure layouts, and human driving behavior. Vehicles train digitally across billions of virtual miles every single day, learning to react faster, smoother, and more intelligently with each iteration. The simulation environments become so advanced that some scenarios are nearly indistinguishable from reality itself. And the most unsettling part is how naturally all these systems communicate with one another. Factories exchange production intelligence globally. Vehicles transmit operational feedback continuously. Charging networks optimize energy distribution automatically. Autonomous systems refine navigation behavior based on collective environmental data gathered from entire fleets operating across different regions simultaneously. Every machine contributes to a growing intelligence architecture, expanding quietly beneath the surface of modern transportation. And as the network grows larger, the machines become faster at learning. Software updates deploy across connected systems almost instantly. Manufacturing algorithms improve assembly timing automatically. Neural processing models adapt to new driving conditions in real time. Robotic systems optimize movement efficiency through continuous machine learning analysis. The entire ecosystem accelerates itself, constantly creating the feeling that the technology is evolving faster with every passing hour. And somewhere deep inside these facilities, surrounded by towering robotics, endless processor arrays, glowing diagnostic systems, and synchronized mechanical movement, the next generation of intelligent machines is already moving through production, silently guided by artificial intelligence systems that never sleep, never slow down, and never stop refining the future in real time.